Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 5.3, example 2, and it can be found on page 219. So we are working on solving systems of equations by eliminating a term with like terms, basically. So yesterday, we had a system of equations that looked like this: 2x plus 7y equals 1, and 2x minus 4y equals 12. And we thought to ourselves, this is great. If only one of these 2x's was a negative 2x, then we could eliminate it, right? So we learned we can multiply this whole equation by -1, use the distributive property. So -1 times 2x is -2x. -1 times -4y is +4y. And -1 times 12 is -12. So we can bring this top equation over. Oh, and would you look at that? When we go to combine these two equations, when we add these two equations, this term cancels or eliminates. We are eliminating that variable x because these terms cancel. So 7y plus 4y is 11y. 1 minus 12 is -11. I need to isolate that variable. So I'm going to divide this side by 11. What I do to one side, I must do to the other. Y equals -1. Yay! Oh, but we're only half done. I get to pick one of these equations, one of my original equations. And I'm going to pick the one that looks easiest to work with. 2x plus 7y equals 1. That just looks easier to work with because I don't have any negatives. I don't know. 7's less than 12. I don't know. It just looks like it's easier to work with. And then I'm going to substitute -1 into my y. 2x plus 7 times -1 equals 1. So 2x minus 7 equals 1. I want to isolate this variable. So I'm going to use inverse operations. I'm going to add 7 to this side. What I do to one side, I must do to the other. 2x equals 8. I still want to isolate my variable. So I need to get rid of this times 2. So I'm going to divide by 2. What I do to one side, I must do to the other. X equals 4. So we know that a solution is always xy. And yes, matters. X is 4, y is -1. Boom. That's what we did yesterday. So we solved a system of equations by elimination because these terms eliminate. These terms eliminate each other. They cancel each other, so they are eliminated, thereby getting rid of that variable x. And then we substitute. And we learned that we can multiply a whole equation by -1 so that we end up with a term that we can use or eliminate. So now let's take that one step further. We have -6x plus 5y equals 25. -2x minus 4y equals 14. So when I'm looking at this, I'm sitting here thinking, oh, if only this negative 2x was a positive 6. If only that negative 2x was a positive 6x. Is there something I can do to make this negative 2x a positive 6x? Why, yes, there is. We can multiply that whole equation by negative 3. Then we can use the distributive property. Negative 3 times negative 2x is positive 6x. Negative 3 times negative 4y is positive 12y. And negative 3 times positive 14 is negative 42. So I'm going to bring this top equation over. Negative 6x plus 5y equals 25. And when I go to add these equations together, I notice that these terms cancel each other. Negative 6x cancels positive 6x. So now we have 17y equals negative 17. I want to isolate my variable, so I need to get rid of this times 17. So I'm going to divide by 17. What I do to one side, I must do to the other. Y equals negative 1. Yay! Oh, I'm only half done. So I'm going to come back up here to my equations, and I'm going to pick the one that looks the easiest to work with. I think this one looks the easiest to work with because it's smaller numbers. It looks like it's easier because it's smaller numbers. Now, I am going to substitute this negative 1 for y. Negative 2x minus 4 times negative 1 equals 14. Negative 2x. Negative 4 times negative 1 is positive 4 equals 14. I want to isolate this variable. So I'm going to get rid of this positive 4. I'm going to subtract 4. What I do to one side, I must do to the other. Negative 2x equals 10. I still want to isolate my variable. So I need to get rid of this times negative 2. So I'm going to divide by negative 2. What I do to one side, I must do to the other. X equals negative 5. So we know that a solution to a system of equations is xy. Order matters. X is negative 5, y is negative 1. There's your solution. Okay. So we're doing what we did yesterday, but instead of multiplying the whole equation by negative 1 so that just our signs change, we multiplied the whole equation by negative 3, which made all of our terms change. And then that gave us a set of terms which canceled each other, which could be eliminated. And then we only had to do one substitution. But life does not stay that simple. Because sometimes the book likes to give us an equation, a system that looks like this. Negative 2x plus 3y equals 7. 5x plus 8y equals negative 2. Now I'm looking at this and I'm thinking, I can't make a 2 a 5 or a 5 a 2 without making it fractions. I can't make a 3 an 8 or an 8 a 3 without making fractions. That's kind of hard. if only I had some way for this to be negative and this to be positive, and they canceled each other. Well, okay. Do we have a common multiple between 2 and 5? Do we have a common multiple? Well, a multiple of 2 and a multiple of 5 is 10. So do I have a way of making a positive and a negative 10? Well, yes, I do. I can multiply this whole equation by 5. That will give me negative 10x. And I can multiply this whole equation by 2, because that will give me positive 10x. So now instead of multiplying just one equation, we're multiplying both equations. So distributive property, 5 times negative 2x is negative 10x. 5 times 3y is positive 15y. And 5 times 7 is 35. 2 times 5x is 10x. 2 times 8y is 16y. And 2 times negative 2 is negative 4. Now I can combine my equations, and I see that this term cancels. Negative 10x, positive 10x cancel. They have been eliminated. 15y and 16y is 31y. 35 minus 4 is 31. I need to isolate my variable. So I need to get rid of this times 31. So I'm going to divide by 31. What I do to one side, I must do to the other. Y equals 1. Yay! But you're only half done. I'm going to come back and I'm going to look at my 2 original equations, and I'm going to pick one. The one that, it can be either one. I can pick either one, but I'm going to pick the one that looks like it's the easiest to work with. And you know what? I'm going to use this equation. 5x plus 8y equals negative 2, because my x is positive. Here the x is negative, here the x is positive, so I think it's going to be easier. Now I'm going to substitute 1 for y. 5x plus 8 times 1 equals negative 2. 5x, 8 times 1 is 8, equals negative 2. We want to isolate this variable. So I'm going to subtract 8. What I do to one side, I must do to the other. 5x equals negative 10. I still want to isolate this variable, so I need to get rid of this times 5. So I'm going to divide by 5. What I do to one side, I must do to the other. X equals negative 2. And we know that a solution to a system of equations is always an x and a y. And yes, order matters. X is negative 2, y is 1. Boom. There's my solution. And we have one more example today. So sometimes you can multiply just one equation so that you have a set of terms that eliminate each other. But sometimes you need to multiply both equations to create a set of terms that cancel each other or eliminate. And let's take a look at this last example. 5y equals 15 minus 5x. y equals negative 2x plus 3. And I know you're sitting there looking at that and you're thinking, whoa, 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 Miss Colburn. I'm sorry, but your equations do not look like these equations. They're not in the same format. Well, that is okay. It's okay. It doesn't matter what form your equations come in. It can be slope-intercept form. They can be in standard form. It doesn't matter, as long as like terms line up. So here, these like terms line up, my y's. Uh-oh. Here I have a constant and an x, and then an x with a constant. We need all of our like terms to line up. So I can rearrange my terms in this equation. 5y equals, and according to the commutative property, I can rearrange these terms. As long as I'm not changing the signs are the same, I can rearrange them. Life is good. I can bring down my second equation. And now look, my like terms are lined up. Here's my y's, my x's, and my constants. They're lined up. Yay. So now I'm looking at this and I'm thinking, oh, 2 to 5, 5 to 2, both negative, I can do that, but there might be an easier way. If only I could make this y a negative 5y. Somehow, is there a way to make this y a negative 5y? Why, yes, there is. We can multiply this whole equation by negative 5. So let's use the distributive property. Negative 5 times y is negative 5y. Negative 5 times negative 2x is positive 10x. Negative 5 times positive 3 is negative 15. So we'll bring this top equation over. 5y equals negative 5x plus 15. And now when we add these two equations together, we have a set of terms that cancel each other or are eliminated. Positive 5y and negative 5y cancel each other. Therefore, they are eliminated. 5y minus 5y is 0 equals negative 5x plus 10x is 5x. And positive 15 minus 15, those cancel each other and we're left with 0. There's an awful lot of zeros here. It's making me nervous. But I still need to isolate my variable. So I need to get rid of this times 5. I'm going to divide by 5. What I do to one side, I must do to the other. Oh yeah. 0 divided by any number is 0. Equals, 5 and 5 cancel, x. Yay, x is equal to 0. Oh, I'm only half done. So I'm going to come back up here to my original equations, and I'm going to pick the one that looks the easiest to work with. I think this one looks the easiest to work with. I can use either equation, but I think this one looks the easiest to work with. Now, I am going to substitute that 0 for x. So y equals negative 2 times 0 plus 3. Y equals negative 2 times 0 is 0 plus 3. Y equals 3. And we know that a solution to a system of equations is always an XY. And yes, order matters. My X is 0, my Y is 3. Boom. There we go. That's what we're doing today. So yesterday, we learned how to solve a system of equations, and sometimes we had to multiply one of those equations by a -1 so that we had a set of terms that canceled each other, that eliminated each other. Well, we don't always have to multiply it by -1. Sometimes we have to multiply the equation by another number so that we have a set of terms that can cancel each other or be eliminated. So we can multiply the whole equation by something else besides -1. It can be positive or negative, just as long as we have a set of terms that can be canceled. And sometimes we need to multiply both equations by something so that we have a set of terms that can be eliminated. And sometimes we need to rearrange the order of the equation so that our like terms line up. Then we have to multiply the whole equation by something so that we have terms that cancel. So that's what we're doing today.